Okay, back here for a hypothesis test for the slope of the least squares regression line. And I'll do a separate video for the correlation coefficient. There's a few little nuances there that differs in terms of how you have to calculate this. But just like if you saw the video with the simple linear regression, ALEKS kind of forces you to use a certain method to complete these problems because it gives you partial solutions for the process. So if you didn't see the other video, what I indicated in there is, let's just suppose in this problem, they do not give you the original data set. If you did have that original data set, you would be able to just go ahead and type those numbers or copy and paste them in here, these fields for X and Y, and then just click the begin analysis. Now, I just type some random numbers in there. And what it then does is produce all the graphs that you would need, a scatter plot that puts the least squares regression line there. And it'll also calculate the least squares regression line and the value for the correlation coefficient. It gives you the residual plots and a dot plot of the residuals. Okay. Now, the part that I really wanted to focus on here, and that is the statistical inference, where you go down to do the, we're going to complete a t-test here. Okay. That is the appropriate test for a test of the, for a hypothesis test involving the slope of the true regression line. And so, this will all be set up here for you. And so when you go ahead and calculate that, what you'll do is just select the t-test. Now, I just want to show you, you could do this for alternate and alternate hypotheses and so forth. And don't get mixed up with this 0.006. This is just for this data set. But I addressed this in the big idea video. All the ones you're going to get are not equal to, okay? And, notice I updated mine there and it doubled it because it was a two-tailed test. But you're going to be able to do all this stuff that very easily just by selecting the appropriate method. You can do the confidence interval for the slope. You can do prediction intervals for an individual response, or you can do a confidence interval for the mean response for a specific value of X. So all this stuff can be calculated very easily with software, and that's typically what's done. But you can't do that here because they did not give you the original data set. So you're going to have to kind of piecemeal everything together that they did give you. So again, just so you don't have to type all or watch me type all this stuff in, that takes a little bit extra time. I hit the solve button here. And, the typical, again, the test that we're going to be running is for linear relationships. So, the slope equals 0 would mean there's no linear relationship, but the alternative, and again, the way they asked their question, they just said they're looking for a linear relationship, not a positive or a negative linear relationship, but just a linear relationship, which means we got to take into account both, thus the not equals. Again, we mentioned the t-test was appropriate for this. So where do all the other numbers come from? Okay, and that's what I wanted to get into. So in order to do this, notice you have a sample size of 25. So remember, for a t-test for a regression model, the degrees of freedom for that t-distribution is going to be 2 less than the sample size. So you'll just have to manually type that in. Now, we also have to compute the t-statistic. And again, that is done, and I addressed this in the video, by taking the value or the estimate of beta, which in this case is negative 0.54, and dividing it by the standard error, which they give you. Okay, so it's a pretty simple calculation here. So, you'll see if I just go ahead and type in the negative 0.54, and then I go ahead and divide it by 0.18. Okay, so you're really given these two values. There's your -3, and that's the value of the t-statistic. Now remember, we got to find the areas in both tails, and that is the statistic. This one goes into the left tail. So if you can visualize that, and I'll show you that in staplets here in a second, but you don't need to do that. I mean, if you can visualize this in your head that you've got this bell-shaped curve and -3 to the left, and all we need to do is find the area to the left of it and also to the area to the right of +3. Now, if you come over here to your ALEKS calculator, you'll notice that it only computes probabilities for a t statistic and finds the area to the right, thus the greater than. So what we'll do is we'll put a +3 in here, and then we'll also multiply this quantity by 2, and that'll give us the area in both tails. And then all I need to do here to finish out the calculator command is enter the degrees of freedom. I hit equals, and there's your 0.006 for your p-value, okay? The last thing you would have to do, obviously, since p-value is less than alpha, that tells us that we do have enough evidence to reject the null and go with the alternative, and therefore our conclusion is there is a linear relationship between the x and y variables in here. Okay, in this case, I guess it's the whatever x stands for here. I believe it is the female life expectancy, and the y, which is the number of births per 1,000 people. Okay, so that's how you do that. Now, if you get a little bit crossed up here, like I said, you don't have to use the ALEKS calculator. I'll show you how to do it in staplets. Pretty simple. All we would need to do is, get into the t distribution. I think I might just open up another tab here for the heck of it. Okay, so I'll go ahead and do that. Okay, so if we go down to our probability distributions in the t distribution, and I just manually enter in my 23 for my degrees of freedom, and there's the curve. I am going to calculate an area underneath there, and I am going to go not between two values, but outside the region. And so my left boundary is going to be -3, my right boundary is going to be +3, and then all I need to do is calculate that. And there is 0.64%. So remember, this is in terms of a percentage. So in a decimal, it would be 0.006, just like we have up here. If I move that decimal point 2 places to the left and round. Okay. So, you can see a little bit shaded there, obviously. It's very unusual to get a t statistic here, if indeed this is true. Okay, so that's why we're rejecting that. Okay, so there's your t-test for a inference for the slope of the least squares regression line. I'll be back with a video for the hypothesis test for one for the correlation coefficient. Again, just to preview that, it's also a t-test, and the t-statistic turns out to be exactly the same. So if we did indeed have our null and alternative in terms of rho, and I do address this, with that Greek letter rho corresponds with our letter r, or the correlation coefficient, everything would be identical in this problem with the exception of the hypotheses. We would just have a Greek letter rho here and here. All right, because again, we're going to do, remember when the correlation coefficient 0, there is no linear relationship, and thus the slope will be 0 also. And of course, if it is, positive or negative, doesn't matter which, the closer we are to 1 or -1 is the stronger the linear relationship. Okay. Now, again, if the question was worded, if we wanted to know if there's a positive or negative, then obviously we would have to adjust our alternative. But I clicked on here and other problems, and I do not believe that you will be asked to do that. So, all right, so that kind of gets into that. The only difference is in that next problem is going to be how I compute t. Okay, we're not going to be able to use the same formula by taking the slope divided by the standard error of the slope. Okay, well, I'll show you how we get that in the next video. All right, we'll see you next video.